Become a sustaining member of the Commonwealth Club for just $10 a month.
Welcome to another program of the Commonwealth Club of California. For 120 years, we have brought innumerable events on topics ranging from politics, culture, society, and the economy to members and to the public. I'm Robert Lee Kilpatrick. I'm the chair of Health and Medicine Member-Led Forums, and I'm a member of the Board of Trustees of the Commonwealth Club. Tonight, I'm delighted and honored to introduce our two speakers whose new book, The Age of Scientific Wellness, was only published yesterday. And they've done one podcast, but this is the first live event that they have done about this book. Harvard University Press has brought it out. A brief background of our speakers. Leroy Hood, to my left. MD, PhD, is the co-founder and CEO of Seattle-based wellness company Phenome Health, co-founder of the Institute of Systems Biology, recipient of the Kyoto Prize, the Lasker Award, the Heinz Award, and the National Medal of Science. And I thought, how much should I say when you have a 75-page bio? So I'm going to stop. In other words, he's a pretty important guy. Nathan Price, on his left, PhD, is Chief Science Officer, Thorne Health Tech in New York. He's a professor at the Institute of Systems Biology in Seattle and a recipient of the Grace A. Goldsmith Award. So clearly, these two individuals are at the cutting edge of the science of wellness and prevention. And tonight, we will learn that the future of medicine is personalized, predictive, data-rich, and in your hands. So without further ado, I'm going to give you Dr. Leroy Hood and Dr. Nathan Price. There are question cards on the seats. If you have a question, please write it down. It will be handed to me, and I'm going to sit in this lovely chair, and we're going to have a conversation. Okay, let's give them a hearty round of applause. So you've written a book, a big book. It's a fancy book. Lee, tell us something about why you wrote this book.
I think the book was written in large part because of COVID, and it gave Nathan and I a lot of time just to sit around and think. And that's only partly in jest, but the real idea is we've been together thinking about what we call precision population health. That is how you can take a population of people and deal with their health individually, uniquely, and powerfully for probably 10 years or so. And this book, in a sense, is a culmination of those ideas. And I'll just point out, in looking at the history of what it meant to be healthy, it's really quite remarkable that prior to the Greeks, there was almost nothing known about health and disease. It was all tied in with the faiths and so forth. But the Greeks made a remarkable series of observations. They said, really, your health, and they defined it as absence of disease, more or less, was really a function of three things. One is the faiths, the second is your behavior, and the third is your environment. And that call is remarkably similar to what we're thinking about today when we think about using phenomics to approach in a longitudinal fashion the assessment and optimization of health. So what I would say is the vision we had for this book was really a simple one. It's the idea that we have the ability with data-driven approaches, genome and phenome, we'll define those to a certain extent later, to assess your individual health trajectory and to optimize your individual health trajectory. And if you think about the word health trajectory, it's really an interesting one because looking back, you can chart your health trajectory as a single historical set of facts. But looking forward, you always have a whole series of alternative trajectories that you can do. And what data-driven health is all about is predicting your future trajectories and choosing the optimal trajectory and pushing you down along those lines. And I'll just close very quickly by saying, to me, health is not a simple binary, the presence or absence of disease. I say health encompasses the three interesting aspects of your health trajectory. We're born in wellness. Most of us at some time undergo a transition to disease. So the three aspects of health are wealth, wellness, transition, and disease. And what we can say from a data-driven process is on wellness, we can optimize your wellness well beyond whatever you may be today. And I would guess most people are lucky if they're at 20 or 30% of their wellness trajectory. And the really interesting question is your will to determine how well you want to be. And where it pays off is in the last 3 and 4 and 5 decades of your life, where wellness throughout your life means you're going to experience wellness into your 90s or even into the hundreds. The transitions are really an exciting part of the book because these appear with this data-driven approach often years before the initiation of clinical disease, and they offer a chance to reverse the disease when it's simple and elegant and straightforward to do so. Challenging, but a new kind of opportunity, and that's the idea of prevention. And finally, disease is what we all know well, and with a data-driven approach, I think we can come to understand diseases in ways we've never understood them before. We're probably not going to get into that tonight because we'd really like to focus on wellness and prevention.
Thank you, Lee. So Nathan, I'd like to shift over to you. Here you are. You have a research lab in Seattle, and you're the chief science officer of a wellness company in New York. What was the driver for you to sit down during COVID with Lee and write this book?
So the book has been something I've wanted to do for a long time, and it was something that I was interested in doing really since I was a kid, and kind of just wanting to have something that I really cared passionate about and wanting to say. And Lee and I have been working together on this notion of scientific wellness for 11 years now. And so we built a lot of time and effort, and we co-founded Aravale together, which was a whole company that rose and fell. We may talk about that. We built a huge amount of research and knowledge and papers coming out of this. And when we first started in this area, it was really interesting because we got tons of pushback. Actually, there were so many people that seemed almost upset that we were starting onto this path of studying wellness, and we had easily 100 people, probably more, tell us this was a waste of time and you would not learn anything. And so as we started on this, I really learned a lot, certainly from Lee, who was, of course, a huge hero in science of mine, and about taking a bold step to say we wanted to do something new and different. And so when we started on this, I really became convinced that the way that we have our healthcare system set up today is off. There's many things about it that are really wrong. And that's not to say, that's not to cast aspersions on people who are in the system. It's really a function of how it's set up. But we have this situation where we deal with disease much too late. Many of us have had this experience. You go to the doctor, you've got an issue that's concerning to you. You can see you're losing your wellness, you're having a problem, but it's early. And so often they will say back to you, do you have this horrible symptom? You say, well, not yet, but you can see the trajectory coming. And they'll say something along the lines of, we'll come back when you have this terrible symptom, and then we'll give you this drug. And that seems very unsatisfying. And so when we think about this, what we call the age of scientific wellness, we're really interested in trying to understand and bring the same level of rigor in science to studying health and to wellness that we have taken to studying disease. And right before the pandemic, I was on a panel with the former chairman of Harvard Medical School. And I loved the way that he actually put this, so I quoted it with his permission many times, which is that healthcare is the only industry that does not study its own gold standard, which is wellness. And I think that is so fundamental that when we go down these paths where we're only studying disease, we actually miss what we care about the most in our lives, which is how long do you get to spend being alive and vibrant with your family, able to do the kind of things that you want to be able to do, and how do we understand the processes that keep us that way such that we can elongate that. And so when we were working down this, and I'm sure we'll talk about a bunch of the science and discoveries along the way, I just became very interested in the notion that we needed to take all of this and turn it into a book so that we could reach out to people like you and try to create more of a movement and some pressure on the healthcare system to say, we need to think about this new paradigm and how would that actually manifest, or how could we actually achieve that, where we could get to a healthcare system that is more focused on the maintenance and extension of health and wellness in a deep way. And so that's really what the book was about.
Thank you, Nathan. I would like to clarify a point for the benefit of the audience. Lee mentioned something about the ancient Greeks and this sort of tripartite system of the fates and behavior and lifestyle, and now the fates would be replaced by genome probably. And you mentioned phenomics. For everyone in this room, can you define what you mean by the phenome and phenomics and why we should all care about that? Because it is kind of the Rosetta Stone for some of your work, isn't it? What is the phenome and what is phenomics?
Well, the phenome is a description of a human as they pass through their life history. So you can imagine a phenome as a baby, as a young child, as many different stages of your life. And in a sense, you have an infinite number of different phenomes. And what we have the ability to do is actually measure the three things that converge together to describe those phenomes. So one is your genome, a second is your behavior, and a third is your environment. And the convergence of those three are what create the phenome. And the kind of assays that you can do that Nathan and I really pioneered were essentially taking a systems approach to the complexity of human beings. Because if you look at it without thinking in terms of the systems, it's incredibly complicated. But basically what the systems approach says is two really simple kinds of things. One is most of your physiology and disease is defined by different biological networks, and we've described many of those, and we can begin to understand the operation of these networks and how they work in physiology and how they work in disease. So the real question is, how can you assess the hundreds of networks that exist in your body? And that's the second fundamental principle, and that's the simple idea blood is a window that lets you look into health and disease. And the reason it does so is because it bathes all of your organs. Those organs secrete molecules into the blood, and we can learn to read the status of those organs by quantifying those molecules from the organ that we measure in the blood. So we measure lots of proteins that reflect many different organs, and lots of metabolites that reflect many different, and the gut microbiome, which tells you about another divergent central population in your health, that is the microbial organisms that live in your gut, and they actually have a very large role in determining your health. So there are three things we're really interested in: your brain and how effective it is, your body and how you can keep it healthy, and your gut. And all three converge together seamlessly. And with phenomics, we can come to understand both the nature of those networks and the nature of that convergence of these major aspects of the body.
So for everybody in this room right now, would it be true to say that every one of us has a phenome, that is to say, you know, our entire physical existence, everyone has a phenome that is unique, just like, you know, a fingerprint. So like yours is not like his. Is that true? And it's dynamic in the sense that it's constantly changing. So the environment can change, the behavior can change, but the genome's not changing. Is that right? The genes?
It doesn't change except in cases like cancer, or there are chemical modifications of the genome that can alter how it releases genes called epigenetics.
Sure.
But the genome as a whole doesn't change. It's yours at the beginning, it's yours at the end of your life.
Yeah, and maybe I can just give an example that I think, you know, might make this concrete, because your genome really provides this map for you to have health. And actually, I'll share one thing about that, which is quite interesting, because when you take a disease focus to the genome, and the genome has really been missold to the public for many years, I believe, because for a lot of time, I think the genome was viewed as like this crystal ball that's going to tell you how you're going to die. And people for a long time were scared to get their genomes done because, oh, it's going to tell you you've got these horrible diseases and there's nothing you can do. And, you know, so let's not find out about it. And the reality is actually the opposite. There's a Native American tribe, for example, that lives outside of Seattle. And, you know, and they're known for having diabetes genes. But they, of course, don't have diabetes genes. They have genes that are very well adapted to their long-term lifestyle that are triggered by, you know, not being suited for a modern diet, which then triggers diabetes. But it's this disease-centric notion that says that's a diabetes gene. Like, no, it's not. It's a gene that says how you should actually manifest your own health. And so as we think about the genome, it gives you a plan for how you can action. And I'll make that even more specific. So some of the work that Lee and I have done is to look at genetic predictions for different measures that are in your blood. So let's take a really common one like LDL cholesterol. So, you know, millions of people in this country are on statins because they have high LDL cholesterol. It's used all over the place in medicine. And it turns out that the level of your LDL cholesterol in your blood is very predictable from your genome. So you can actually predict whether someone's likely to have high or low cholesterol. So today, because medicine ignores the genome, we actually treat everyone that has elevated cholesterol the same. So we ask the question, is there a difference in whether or not you could lower your LDL cholesterol by lifestyle that is predicted by the genome? And it turns out, yes, the genome will predict whether or not you are able to lower LDL cholesterol by lifestyle. And so the key variable, it turns out, is if your genome predicts that you have low LDL cholesterol and you're high, i.e. there's a gap, you can change it. And if your genome predicts high and you're high and you try to change it by lifestyle, we saw no statistically significant ability for people to do so. And that was in the top 40% of individuals. So a very large swath. This was done on thousands of people. So what you can imagine then is a gap that you have. And by the way, this is true for LDL cholesterol. It's also true for HDL cholesterol, the so-called good cholesterol you're trying to raise. It's true for hemoglobin A1C, the predictor of diabetes or the diagnostic for diabetes. And so your genetics relate to, for example, the residence time of your red blood cells. So for most people, your red blood cells circulate for 120 days. Hemoglobin A1C that your doctor uses is glycosylation that comes on, that's accumulated on this protein. But if my genetics let my circulation go 130 days and yours is 110, then a high hemoglobin A1C reading for me would not be as important as it would be for you. And so those are some specific examples, but you can multiply that out. And so what this does is actually give us a completely new class of variables into medicine, which is not just the biomarkers that they're used every day, but the genetic prediction for all those biomarkers and what they are, and the gap, whether it exists or not, is a highly useful variable for knowing what is it that you could do for your health that would make a big difference to you right now, today, that would be easy for you to change because your genome will work with you rather than against you. So there's many ways that this static genome relates to that dynamic phenome.
And I would just add there are about 150 disease and disease phenotypes that have been described with these polygenic scores that allow you to determine genetic risk. And I'd argue every one of us ought to know what our risk on all those genes are, because then you can inform your doctor about how to treat you in really interesting ways. And that's something that I think will come out over the next 5 to 10 years. We have to train the physicians before we're going to get them to accept it as therapy for their patients and so forth. But that is coming. Right now, we could take your genomes and we could give you the genetic risk calculations for 150 different conditions. And many people are terrified, gee, these are bad things to know. They will depress me. But the counter way to look at it is, if you know the things you're likely to have difficulties with, you and your doctor can keep track of it. So when new therapies and new approaches come, you can deal with it effectively. And you know, too, how to treat yourself in the context of these various diseases as well. So there's, I think, compelling arguments for identifying genetic risks for every single individual.
So you both taken the deep dive now into science. You've opened that door at last, which is a good thing. For a lot of us in this room, when we think about wellness, we might think about traditional wellness, massages and diet and exercise and smoothies and that kind of thing. The scientific wellness, I've heard some people say they don't even go together. I don't understand what that means. So here's an opportunity. Why don't we open that door to the question, what is the title of your book? What does it mean? Scientific wellness.
Yeah, I'm happy to take that. So it was something that Lee and I actually debated a lot in the early days of whether we would use this term, because there is, at least certainly in the scientific community, a bias against the word wellness. And this was one of the things that I think people kind of got upset about at the beginning when we started down this path. And we argued for it for a long time, but we didn't end up believing that there was another word that quite captured what we wanted, which was something that was kind of in the exact opposite of disease. Wow.
It's just technology.
That was kind of, that would give the notion of being in the opposition to disease. And then we basically attached the moniker of scientific wellness to try to differentiate and say, okay, we want something that's in that direction, but that is taking the same sort of deep dive that we have done in all this science of disease that we've done. And it was really interesting, I have to say, because we got into this nexus between these two disparate worlds that basically don't talk to each other very much. So one is the hardcore science world that Lee and I come out of. And a lot of them would look askance at some of the things that are happening in wellness. And then on the other side, we would have people on the wellness side, and sometimes some of them I think are really well rooted in science, and some aren't. And I'll give a couple examples just to make that clearer. So for one, on the science side, we'd have all these physicians. They say, "Well, I don't believe in any of this stuff," but you'd go to their meetings, and they just serve pastries at the back. Half the people there are obese, and they don't look that great. And I'd go to some of these, like functional medicine doctor meetings, and a lot of them would look askance at functional medicine. And I say, yeah, but everyone there looks amazing. And so I think they know something, so we'd get into these like interesting nexus of back and forth. The other thing that I'll share, though, which was interesting, is this: as you get into the wellness world, there is definitely a huge difference between people that are science-driven and going. I'll just share an example. So after I gave a talk at one of these meetings, a person comes up to me and they say, "Oh, we have the best probiotics in the world." And I'm intrigued. What makes them so great? And so when you measure a microbiome and you give people these probiotics, what happens? Turns out they've never done that. I don't think they know how to do that. And they kind of slinks away. I end up looking online later just out of curiosity. Oh, I've left out a part. What he actually said was, he says, "Oh, we brew these for 2 years until they're just right." And I'm like, "Oh, okay." I'm like, "Well, these things double like every 30 minutes and they don't have a very long lifespan." Okay, you can have some longer effects, but this seems unlikely. That's what I asked him the question about, the measurements, and he kind of slinks away. So I look online, and it turns out on the advertising, what do? During those 2 years, they play Mozart to the bacteria. And so there is this like morass that gets thrown around wellness, where there are so much, kind of nonsense that gets thrown under that umbrella term. But by the same token, there's so much from what we talked about earlier, from this only studying late stage disease and being so focused on that. And so we tried to pull those disparate worlds together with this terminology of scientific wellness was the best we could come up with to try to describe how we pulled those worlds together.
And you might think of scientific as quantitative too. Wellness, we use that rubric as well. One of the other important points about there are really two kinds of wellness now. So there's the traditional wellness, and there are 100 companies out there that deal with diet and sleep and exercise and stress and similar kinds of things. But what they uniformly do is they have a simple formula for everyone that everyone practices. The second kind of science is this data-driven science, which Nathan and I have pioneered. And what is interesting about the data-driven science is it can come back to the traditional wellness and actually tell you what kind of exercise each person should have, what kind of diet each person should have, how you can uniquely deal with and things like that. So what data-driven science can do for traditional science now is personalize it.
Well, that's a good thing. At the end of your title, there's the title and then there's the subtitle. And the last 3 words of the subtitle is "in your hands." So on behalf of everyone in this room, because we at the Commonwealth Club just love to let our members leave a talk with specific ideas about what we can do to improve our lives, what does the science tell us, Nathan and Lee, about how the science of wellness can put it in our hands, and what can we do that is scientifically correct in your view? It said in the New York Times, the single best thing today I read was to exercise, go for a walk every day. I mean, that like walking apparently is amazing. Does the science support that?
Absolutely. Yeah. Walking every day is very good. There was a fascinating scientific study that was done a few years ago, and I'll just talk about some of the table stakes wellness, and then I'll talk about some things you can do from this more quantitative style of wellness. So every hour that you run, on average, adds 7 hours to your life. So when you run, you get the hour of running and you get 6 more, you get 7 more hours of life. And you might be thinking to yourself, like, how is that possible? That's certainly what I thought when I saw that, when I saw the paper. And of course, it wouldn't be if you ran all the time. It's not like you would never die. But typically, if you go out and you run, right, if you run a few hours a week, you actually make up in terms of lifespan enough years that if you do and I did rerun the calculation because I wanted to make sure they were actually right. It turns out that is correct. So you actually get an incredible return on that investment. So there's no doubt that the very basic things like sleeping, your 8 hours, getting sunlight in the morning, going for runs, strength training is really important. I've been ramping that up a lot lately to try to get that in motion. Lee's been a fanatic about that his whole life. And so as you're doing these things, because as you get older, that starts coming down. So there's all these things that you can do to prep. Now, on the flip side, there are so many really interesting things that are emerging that are more quantitative, and also that we're trying to look at in terms of having an effect on aging and health span. So some of the things that are available now is that you can do much more personalized testing than before. I'll give one example that we've done at Thorne, which I think is quite interesting. So one of the things that you can measure is your microbiome. And the microbiome actually tells you and we're learning more and more about it all the time, how it can have big impacts on health through its effects on inflammation, on digestion, breakdown of food, nutrients, everything that comes into your body, whether it's a drug or a supplement or food, passes through the microbiome, and your microbiome modifies those things. And we could get into a whole bunch of examples of that. So one of the barriers, though, is for people to actually take a microbiome test. So I don't know how many people in this room have done microbiomes, in addition to Lee and I know a few people here probably have. But it's not the most pleasant of things. So, what do you have to do? You have to poop in a bucket or on a piece of paper. Take a little shovel, you got to scoop up a little bit, you got to put it in a vial, close it. Some of the tests actually require freezing. I don't know what you keep in your freezer, but I generally keep food there. And so I don't know if you have a sample freezer. So one of the things that we've had to deal with at Thorne was to look at, is there an easier way to get a sample? So we invented something called the microbiome wipe. Exactly what it sounds like. And so what this does is this lets a person get access to a sample by just wiping like you do every day. We invented a special polymer that you do that, you can put it in a vial and close it, you shake it, and in 10 seconds it will dissolve away. And we published a paper showing that we could get high quality DNA sequencing off of that. And it was really interesting on the Huberman Lab podcast, if you listen to that one, Sarah Gottfried was on there, so a really well-known physician and friend. And she actually is working with one of the NBA teams. She said she could never get the NBA team to do the microbiome, but as soon as she switched to the wipe, they would all do it. And so you're able to get data like that. So anyway, I just wanted to use that as an example because part of this is doing innovation to try to make the barrier to being able to collect this kind of data just easier and simpler and of course cheaper and all those kind of things. And so that's a big element as we think about how to make scientific wellness accessible, is how do we let people get to personalized testing and solutions that will make a difference. And then in the big picture, what we're really looking at is, can we take health span that is achievable by all the table stakes things we do in wellness, and then flip that to, as we start understanding the basis of aging and how we slow that down and all those kind of elements, can we start to really elongate the health span for all of us? And that's what we're really trying to do.
And, I'll add to that, Robbie, just one thing. In the early 2000s, when we were applying systems thinking to medicine, we applied it to healthcare, and we came to the conclusion that a general description of healthcare is that it should be predictive, preventive, personalized, and participatory. And the first 3 Ps, prediction, prevention, and personalized, all have to do with science. And we really know how to do the science now. The 4th P, the participatory, the idea that people have to participate in the process. And the people include patients, they include physicians, they include healthcare leaders, they include healthcare technology people, they include regulators, and on and on. How do you persuade people in a system that there's a much better system that they can switch to? And that's turns out to be a sociologic, psychologic, economic. Actually, it's an enormous educational challenge and problem. Just how do you get patients to want to drive their own wellness? And I would say the best single thing you can do is to teach them in grade school, this is really important. So recently at ISB, we've developed this 20-unit course on systems medicine that seniors in high school can take. And the kids, and this was designed by the teachers, by the students, and by the Logan Educational Group that we started at ISB. And I would argue the kids that graduate from this course will know more about the future of medicine than 98% of the doctors that exist out there today. And that's one very important way we have to push education for people, get people to want to realize what are the components of health and how much control you have over those components.
So I've got a couple of really good questions from the audience, and one of the characteristic features of the Commonwealth Club is that we do encourage this kind of discussion, so do fill out the form if you have one. Pardon me. These are really about money, because in the United States, healthcare is about money. It's a business. So can we pay people to stay well? So we pay people to work, and we, in a way, pay people who are sick because we take care of them. Is there a model? I know you're not economists. Can we pay people to be well?
Yeah, it's a great question. I want to take it in two parts. First, to talk about economics of prevention and the perception, and then I'll come back to that question. So the first thing that's really interesting is that when you want to deploy anything that's focused on wellness and prevention into the healthcare system today, there's basically a requirement that it has to save money. And so you're really forced down that path.
Pardon me.
Now, I'll talk about that in a moment, but one thing I want to point out is, on its face, you think, okay, yeah, that makes sense, right? We want to save money. That makes a lot of sense. But we never require that a drug or a therapy is cost negative. We pay for it. So what we have decided as a society across our system is that a year of sick life is worth a lot, and a year of healthy life is worth nothing, which is a very odd position to be in. And I'll actually argue that that kind of economic basis only makes sense from the standpoint of a system that is totally dominated by a disease-centric view of the world. So the notion that a year of healthy life is not valuable economically is of course crazy on its face. So that's the first thing I'll say. So the second element is, though, absolutely right, and it's the biggest barrier to implementing the kind of vision that we talk about in the age of scientific wellness, which is that there is a huge entrenched system that profits off of the current system. It's nearly 1/5 of the economy. It's been growing faster than inflation for decade after decade after decade. And so the notion that we can turn that quickly is, you can't, basically, right? It's a Herculean effort to try to shift that. And there are many entrenched interests that profit off of the current model. So then the big, huge question, of course, is how do we set up systems such that we get something that is better? Now, partly what that is that a lot of what is going to drive scientific wellness, I think, in the future is not going to originate, at least initially, from the existing healthcare system. Some people will. There's going to be pockets, right? There's going to be elements that adopt that, but it's going to be a hard sell. So a lot of this, and and I wrote an article on this for the special issue that Lee and Robbie spearheaded from Phenome Health and for Scientific American, is this emergence of a scientific wellness industry. So a lot of this is going to start from individuals who are just doing this for themselves, who have some disposable income and are willing to spend it on arguably the most valuable thing that you can, which is to extend your health and wellness. We are looking into various ways that we might be able to get insurance companies interested in this. Different populations, I think, that are going to be really interested in this, though. One are large self-insured companies. So if you're a large self-insured company, if you get, that's an area where you actually have an economic incentive. God, that thing is not going to stay. That you actually have an economic incentive such that keeping your workers healthy, you actually benefit from that productivity, which is one. Second is you save all the money directly on anything that doesn't go into their healthcare system. And so those pockets, I think, are some of the elements where we'll be able to drive this into there. And then as you get enough data that shows that, in fact, all of this is really cost saving for people, which is the paradigm that we talked about before, then you'll be able to drive more and more adoption. So it's really, the onus is on kind of creating these pockets that work much, much better than the current system, demonstrating that, and then I think we'll be able to push adoption across the system. But it will be sort of, small, growing, and then hopefully you cross a turning point and you start having a real impact.
Well, I think the other point that's really important is we can show that scientific wellness is really going to lead to enormous savings in healthcare. And I'll give you just two simple examples. If we can really predict for each of you the time at which you're going to transition to your first major chronic disease and prevent it, that's going to save the healthcare system enormous money, because today we spend 86% of our $4 trillion a year on chronic diseases. And suppose you could cut diabetes and cardiovascular disease and cancer in half. You can do the calculation about what it would save. Now, who's going to benefit most from those savings? It's the payer end of things. And the ideal partner for us would be a payer provider that are integrated together. Kaiser is one example of that kind of thing. And because then all the money that the payer saved also benefits the provider. Whereas if it's a payer alone, the provider over here gets nothing by themselves. But anyway, that is a potential big saving. The other big saving is there was a paper in Nature about 3 or 4 years ago that looked at the 10 top-selling drugs in the U.S. today and demonstrated that of the 10, less than 10% of the people responded effectively to those drugs. And it varied from the best, which was 1 in 4, to the worst, which was 1 in 25. And with this data-driven approach, within a few years, we should have wonderful biomarkers that will tell you for all the major drugs who's going to respond and who doesn't. And straight away, you could save 90% of the $6 billion a year that we spend on drugs, which would again be a remarkable saving. Being cynical, what Congress would probably use the money with is to start a new war, but which is what's happened in the past, frankly.
So on behalf of the audience, again, since they want to go out of this building with something exciting to do, what's your view on whether or not all of us should go out and have a genome analysis with interpretation? And so would you recommend we do that? And if so, why? And secondly, what's that going to cost us, do you think?
I do believe in doing genome analyses. I think they've come a long way. I think the genome in isolation is only kind of useful. I do think the genome in combination with the phenomic measurements we talked about are really useful. And I'm especially, we're going to be trying to build this out to make it easier for people, but I really think that this gap between the genetic prediction and your actual level makes a huge difference. I think that's really important. Genetics can give you a real view into what is the highest risk categories for you. So that can make a real difference in terms. So if you have ApoE4, for example, high risk for Alzheimer's, I have one copy of ApoE4, so I know that about myself. Well, there's a whole host of things that you can do to modify that. And in fact, there are multiple risk factors that are associated with modifying your risk for Alzheimer's that you can change. And in fact, we've developed with people here in the room, Tom and Jen over there from, with Embody Bio, which is we discuss in Chapter 8 of the book, these deep digital twin models that can actually monitor for when it is likely that you might, at what age at which you might fall into dementia. And also interventions that you can do and projections of how far into the future you can push that. So that's something that we'll be getting out soon. So there's all kinds of things that you can look at and do that will make a difference. So knowing that risk. And in terms of cost, well, you can get most of the known actionable genetic variants today on a SNP chip. For someone like, I spoke at 23andMe at noon today, so they've got a product, it's about $50 for you to get that. Whole genome sequencing now you can get for as low as about $100, depends on how much depth of sequencing you go, and you can go up depending on how high quality you want. But genomics is cheap. And so I think, and Robert Greene at Harvard, who's a colleague who's done a lot of really amazing work on this space, in essence, is really pushing towards this vision, which I think is going to happen soon, where we may just do genomes on everyone at birth, everyone who consents at birth, with the parents' consent, because it's going to be so enormously helpful to the healthcare system. And I think within a decade, we will look back on, on healthcare where we didn't use the genome as just totally archaic. So I think we're moving towards that. It's been slower than many of us thought, but I think that turning point is finally upon us, and it's now cheap. There's obvious huge benefit, and you can do it.
One thing I'd add is there are of the order of 600 genetic variants in your genome that predispose you to athletic injuries. So, for example, ACL tears can be beautifully genetically determined. And the important point is, if you know about this deficiency, there are exercises you can do to circumvent it. And of course, professional athletes are really terrified from getting their genomes done because, gee, could owners use this against them? But the converse is, look, knowing their genome, you could prevent all the major damage that these things could bring. So we have to work those kinds of conundrums out, I think, in the future.
I'd like to shift gears a little bit. Recently, I was able to visit the Buck Institute for Research in Aging in Marin County. It's an incredibly dynamic environment, and Eric Verdin, who's the CEO, is going to speak here next month on HealthSpan. And I know both of you, as part of this scientific wellness, have ideas about, I've heard you talk about how aging is a major risk factor for chronic diseases. Can you say something about that? And is aging reversible? Lee?
So aging is the major predisposing factor for all chronic diseases. That's absolutely a given. So the really interesting idea is, if you could back your aging process off even a few years, you could make an enormous difference in when you'd get to the point to start chronic diseases. And in fact, an aging expert, David Sinclair, has done a calculation on if you could slow aging just a single year, he argues could save the healthcare system up to $35 trillion. Now, I have to say, I think that's a little on the expensive side, but it emphasizes this really important point that if you can slow the aging process, you slow all disease processes and delay them. And it turns out, I think what I find so absolutely incredible about aging is there are a few very deep fundamental mechanisms for aging that seem to be highly conserved from yeast, a single cell organism, all the way up to humans. So when we do experiments on animals like dogs and mice, they have enormous implications for aging for us. And I think what's really exciting is there are at least 2 or 3 drugs now that are well along the road of validated anti-aging drugs, rapamycin and so forth. And maybe Nathan wants to talk about how Thorne is going to approach this kind of problem too.
Sure. So, as Lee said, aging is obviously the most, the biggest risk factor in all disease. Aging is today, I would say, reversible to a point, and it depends on exactly how you define aging. So the definition of aging that I most like is, so every year you're alive, there's a certain probability that you'll die this year. And every year you get older, that probability increases. And this is an example from when I was studying chemical engineering back as an undergrad. But I remember this example, I don't know why it stuck with me, that light bulbs don't age. And and what's meant by that is that a light bulb is just as likely to burn out in its 30th year as it is in its first day. Like every day is the same because it's just a function of the power grid, right? It doesn't get older, the filament's not wearing out, that kind of thing. So when we talk about eliminating aging, just from a definitional standpoint in humans, to me that is that your risk of dying is not going up year over year, it's flat. And right now it is incredibly steep. So at one fundamental level, the notion of reversing aging is not even controversial at all. If you are controlling your cholesterol and your hemoglobin A1C and you're getting healthier and you're losing weight and you're, all those different things that you might want to do, that is improving your health. It is lowering your risk of dying, and that trajectory of aging is in a sense be reversed. Now, that doesn't get us to where we ultimately want to do, which is that we'd love to basically have the body of our, late 20s or whenever you want, like in perpetuity, that we could just be healthy and strong and not lose that decay. And there are a lot of scientists that are currently working on that, and that seems to be not entirely a pipe dream in the sense that, we can get some of these things to work in people now, or in animals, and then we're working on them in people. Now, there are a number of compounds that I think are pretty interesting in this regard. Now, the evidence for these compounds typically are that they have extended health span in a wide variety of animal models. They are conserved mechanisms, and we can see that they have effects on the similar biology in humans. But for all these compounds, I would say we don't yet know if they're going to have a real impact on lifespan because it just takes a while. But some of the ones that are interesting, which I take, because am I supposed to take a shot? Nicotinamide riboside, for example. So NAD boosters are one of these areas that people are really interested in. The 2 big categories being, nicotinamide riboside or NMN. I won't go down that rabbit hole at the moment. Quercetin and a drug called dasatinib are interesting for, there's some evidence that they might clear senescent cells out of the body. These are these dead cells that you accumulate over time. So those are of interest. We've just run some animal experiments, that are showing a couple of extracts from basically compounds that you can find in vegetables and so forth. When we give them to worms, extends their health span pretty significantly. We'll publish that here shortly. So there's all kinds of different things that you can get into that have an impact potentially. So it's really it's a very interesting space to watch. As Lee mentioned, there's rapamycin, there's metformin. There's a big clinical trial being led by Nur Barzilai at Albert Einstein in New York looking at this. So it's an area to really watch. And so for me personally, I look for any compound that shows good efficacy against animals, has safety data in humans that looks really robust, and that hits a mechanism that's fairly conserved. and try to keep a catalog of those as we go forward. And we talk about some of those in the book as well. And then the hope is that those will start to have an impact. And then the real question is as you start putting these things all together, does it become possible to do like next generation changes, which would be things like epigenetic reprogramming, trying to get your cells to reverse more, healthier stem cells, elongating telomere. There's all this like really deep biology that you can get into. And so that's kind of how I think about it. There's all the stuff you can do lifestyle, which is very safe and will make a difference. There are these like natural compounds that you can look at that have big effects in animals and are very safe in humans, so are easy to do. And then there's this like next generation of, wow, maybe some of those dream scenarios could come true, but they come with higher risks and there's a lot more work that has to be done. So it's kind of this pyramid that we're working on towards the reversal of aging.
And the final thing I'd say about aging, which is really important, is clearly you'd like to have a metric that can assess how well you're aging. And in this Aravale population with 5,000 people, we had individuals from 21 to into their 90s. And we were able to develop an algorithm there that basically was able to give you your biological age. So that's the age your body says you are, as opposed to your birthday. And the lower the biological age is relative to your chronologic age, the better you're aging. And we use this to demonstrate there were people that had a variety of diseases in Aravale, and essentially every person that had a disease had a biological age that was greater than their chronologic age. And conversely, we looked at people that were in the upper 5% of Fitbit exercise, and we were able to demonstrate on average they were 3 or so years younger than their biological age. And actually the most remarkable is Nathan, who was in this study of a 4-year period, and he lost of the orders of 10 years of biological age during that period of time. So you clearly can learn to age better. And what's even more exciting is because we use metabolites to measure these things, we can actually tell you the biological age of your kidney, of your liver, of your immune system, and so forth. And those can be very different from one another, but you can get specific advice on how to optimize the aging of each of those different kinds of systems. So with the metric, you change entirely how we can begin to assess biological aging in the future.
So, gentlemen, we're near the finish line. We have about 2 minutes to go. So I'll give each of you a minute. Can you tell the audience what you think the single most important point is from your book?
I'll start.
Go for it.
I think the single most important point from our book is we're within striking distance of being able to transform healthcare from being disease-oriented and bring it around to being wellness and prevention-oriented. And that will change the productivity, the creativity, the life quality, and the health span. Virtually everybody that's willing to adopt this new approach to health.
I agree with that as really the main point, and I'll just add that I think the biggest take-home would be that you can really have a major impact on your health today, that the science has moved a long way, and that, just as I alluded to at the beginning, there were these doubts about what could you learn from studying wellness. We've only scratched the surface in the hour we've spent together here, but the ability now to really dive in and get access to data, information, tools that can make a real impact in your life has just never been better, and it's an incredibly exciting space.
The program has come to a close, and I want to thank all of you for making the effort to come here in person to hear this fabulous discussion with Dr. Leroy Hood and Dr. Nathan Price. And I'd like to thank everyone who followed this program online. In about 10 days' time, it will be available free of charge on the website, and you can share it with your friends. And come next month to hear Dr. Eric Verdin from the Buck Institute talk about HealthSpan. So let's give a great warm thank you to our speakers today.